Today we're going to be talking about absolute value. And in order to appreciate absolute value, we really need to differentiate how it's similar to but not quite the same as an opposite. And in order to understand either absolute value or opposites, we really want to have a solid understanding of what it means to be an integer on a number line. So in particular, on the right side of the number line, we tend to have our positive integers. And on the left side of the number line, we tend to have our negative integers. And 0 is basically our differentiator that's neither negative nor positive. It's really its own thing. And if we're talking about, let's say, the number 2, if I want to know the opposite of the number 2, that's asking 2 plus what number is going to give me 0? And you might be thinking, oh, well, I do 2 minus 2 to give me 0. Well, that's the same thing as adding a negative 2. So 2 plus negative 2 is 0. And really, that question works the other way around, because if I ask for the opposite of negative 2, that's asking negative 2 plus what gives me 0. And if I start at negative 2, I'm going to do negative 2 plus a positive 2 in order to give me 0. So really the opposite of a number, also known as the additive inverse, if you want to sound very mathematical, is just the opposite sign. So if it's positive, the negative version; if it's negative, the positive version, such that when I add the two numbers, it makes 0. And that's all this is saying in more formal language. So go ahead and pause your video and see if you can write down what the opposite of 7 and the opposite of negative 5 are. Well, the opposite of 7 is negative 7, because 7 plus negative 7 is 0. And the opposite of negative 5 is 5, because negative 5 plus 5 gives us 0. So let's keep on going through some more definitions, because in particular what we really want to focus on here is absolute value. Absolute value is not the same thing as an opposite. That's a common misconception. What absolute value is the distance from 0 for a number. So let's say we're dealing with the examples of the 2's again. So if we have 0, 1 positive 2, negative 1 negative 2, for both of these numbers, if I asked you, what is their distance from 0? Well, positive 2 is 1, 2, 2 away from 0. Notice how it's still a positive number I'm talking about there, because when I talk about distance, I tend to talk in positives. Similarly, negative 2 is 1, 2 away from 0, so it's also 2 away from 0. So that would mean that the absolute value of both 2 and negative 2 is 2. The way we would indicate that symbolically is we're going to use these straight up and down bars. So that reads as absolute value of 2 is 2. Similarly, the absolute value of negative 2 is also 2. Another way that people tend to remember this is that if the number is already positive or at 0, the absolute value of the number is equal to itself. While if the number is negative, then the absolute value of the number is the negative version of that number. So for example, the absolute value of positive 4 is simply 4, while the absolute value of negative 3 is 3. Go ahead and pause this video and check your understanding by practicing these 3. For example, this reads as the absolute value of negative 4. The absolute value of negative 4 is 4. The next one reads as the absolute value of 5. The absolute value of 5 is 5. And conceptually what we just said is that negative 4 is 4 away from 0. Positive 5 is 5 away from 0. The absolute value of 0 is simply 0 itself. 0 is no distance away from 0. 0 is already at 0. Don't have to move any further. 5 is 1, 2, 3, 4, 5 away from 0. Negative 4 is 1, 2, 3, 4 away from 0. And don't hesitate to draw a number line if you like. And this is just a nicer number line of what we went over earlier about 2 and negative 2. Now, if you're going to simplify expressions with absolute value, you want to first simplify what's inside of the absolute value symbol. In terms of order of operations, you want to treat absolute value sort of like it's a special parenthesis. Order of operations wise, you're going to always attack whatever's inside there. But then remember, those absolute value symbols are an operation themselves. After you simplify what's inside there, you evaluate the absolute value. Then you want to evaluate the rest of whatever's going on the outside of the absolute value according to order of operations. Keep in mind that if you see a negative just hanging out by itself, that's really multiplication by -1. So it might be helpful in a lot of instances to rewrite that explicitly as times -1. And let's look at some examples of that. So for example, the absolute value of -75 would be saying -75 is how far away from 0? It is 75 away from 0. And the -75 was the only thing inside the absolute value symbol, so there wasn't anything else to do besides evaluate that expression. That's different from the next one here. On the next one here, the negative is on the outside, so I would want to personally rewrite that as -1 times the absolute value of 3. That's really what's going on there. That negative hanging out on the outside is the same thing as multiplication by -1. Now I can evaluate this. The absolute value of 3 is just 3, and then 3 times -1 gives us -3 as a final answer. Similarly, on the next one, I'm going to encourage you to pause the video and try that yourself and then compare with what we get. So for this next one, I'm going to rewrite that as -1 times the absolute value of -6. The absolute value of -6 is 6, and now I'm ready to do that -1 times 6 is -6 as our final answer. Now, if you're having to compare numbers, I would encourage you to simplify both expressions before actually doing the comparison. When it comes to the comparison itself, keep in mind that we always point to the smaller number and read left to right. So this first symbol, for example, is less than, because we point to the smaller number, eat the bigger number. The second symbol is greater than. And then the last one is equal to. So let's evaluate some of these in order to compare them. So for this first one, where I have negative absolute value of -4, that means -1 times the absolute value of -4, which is 4. So that really simplifies down to -4. For the next one, I have the absolute value of -4, that is 4, because the absolute value of -4 is 4. So here this is really asking, how does -4 compare to 4? Well, we can visualize that on a number line. We have -4, which is the same thing as negative absolute value of -4, tomato, tomato. We have 4 over here, 0 in the middle. -4 is to the left of 4, so -4 is considered smaller than +4. So that would be the symbol that we use. Similarly, on the next one, 7 is already simplified. The absolute value of 7 would simplify to 7. And 7 is exactly equal to 7, so those two expressions would be equal. Let's say we have a little bit more going on inside the absolute value symbol itself. Well, the steps are really the same, so we're still going to simplify whatever's on the inside of that absolute value. Then evaluate the absolute value part itself. Then evaluate whatever is on the outside remaining according to order of operations. So let's take a look at some examples. So for example, if I have the absolute value of 4 minus 6, that 4 minus 6 gets us -2, and then the absolute value of -2 is 2. For this next set, I want to encourage you to go ahead and pause the video and try it yourself, and then we can compare answers. For example, the absolute value of 4 minus 5 is asking for 4 minus 5 gets us -1. And then the absolute value of -1 is how far away is -1 from 0? It's 1 away, so that's just 1. For the absolute value of 8 minus 5, well, 8 minus 5 gets us 3. And then the absolute value of 3 is just 3, because 3 is 3 away from 0. This next one has 3 numbers, but just work left to right. So I would first simplify that 8 minus 5 gets us 3, drop down the -4. Absolute value of 3 minus 4, well, 3 minus 4 is -1. Then the absolute value of -1 is 1. Same thing happens even if we have absolute values inside of absolute values. I would encourage you to highlight where you have an absolute value inside of another absolute value when approaching such expressions though. So for example, if I have the absolute value of the absolute value of -26 minus the absolute value of -22, well, I might want to first simplify that the absolute value of -26 is 26. The absolute value of negative 22 is 22. Then 26 minus 22 will get me 4, and then the absolute value of 4 is just 4. You want to do it step by step just like that, otherwise you're going to get really confused by, so many nested absolute values instead of absolute values, especially if they get a little bit creative. That can be a lot to keep track of in your head. Definitely write it down. So let's actively practice that. If you're feeling confident, go ahead and try this first one yourself. Otherwise, if you want to see one more sort of explicit explanation before trying it, go for it. So here, I'm going to highlight that we have 2 inside absolute values, and I'm going to evaluate both of those. The absolute value of negative 77 is 77. The absolute value of negative 32 is 32. And then I'm just going to drop down all those remaining symbols. So there was an absolute value on the outside, and there was a subtraction symbol in between. Then I'm going to actually do 77 minus 32, and if I'm feeling a little lazy, I'll just kind of do that off to the side rather than doing that in my head. 7 minus 2 gets us 5. 7 minus 3 gets us 4. That boils down to the absolute value of positive 45. Absolute value of positive 45 is 45 as our final answer, because 45 is 45 away from 0. If you haven't already, I'd encourage you to pause to try the next ones yourself before I go over it. So for the next ones, absolute value of 7 is one of our inside ones. Absolute value of 7 is 7. Absolute value of negative 9 is the next inside one. Absolute value of negative 9 is 9. I'm going to pop the symbols around it. Then we still need to simplify a little bit further because I want to have a single number by itself there in the absolute value symbol. 7 minus 9 gets us negative 2. And then the absolute value of negative 2 is 2 because negative 2 is 2 away from 0. If I see division like this, remember divisions and fractions are really the same thing. So this is really asking negative 45 divided by the absolute value of negative 45 if you're a little bit more comfortable with the traditional division symbol. As you get further into college work, fractions are going to be consistently used for division because it's a lot less clunky. It's just simply what we prefer to convey the operation of division. Either way, though, what we're going to tackle first is the absolute value of negative 45, which is going to give us positive 45 because negative 45 is 45 away from 0. Then what we're down to is negative 45 divided by positive 45, since the absolute value of negative 45 is 45, and that will give us negative 1 as a final answer. As a preview to some a little bit more interesting ones, remember that the order of operations really always applies. And just in terms of order of operations, the P in PEMDAS, that is really like the absolute value. Those absolute value symbols are like a parenthesis. So if you're going through these order of operations with something like the beginning here, you would first tackle, hey, for the parentheses in PEMDAS, I need to tackle these absolute value symbols. And then you're going to zero in on what's going on in the inside there. The next thing you're going to approach is multiplication and division, which remember multiplication and division is really the same step in terms of order of operations. But I have a 7 times 3 here that we have to tackle. Well, 7 times 3 gets us 21. Then we're going to move on to addition subtraction inside that absolute value. Well, 5 minus 21 gets us negative 16. Now that we have a single number inside the absolute value, we're ready to evaluate the absolute value part. The absolute value of negative 16 gets us positive 16 because negative 16 is 16 away from 0. Finally, 4 plus 16, we're now ready to tackle what's on the outside of the absolute value expression, leaves us with 20.